Hello there. In our previous tutorial video, we got much more familiar with the Lutensil XBF-LD02S card and even tested it out together. Today's brand new tutorial is all about getting to know exactly how to program this specific card. Please stay right here with me for the details. All right, let's open up the XG5000 software environment. After entering the software environment, in the I/O parameter section, first we select the PLC model here. As I explained to you in the previous tutorial, the PLC we're using here is the XEC Dr. 32H, and in slot 1 we have the Luteful card. We need to add it here, so let's go to the Special Module List section and select the Load Cell card there. We selected. One extremely important point that you really need to keep in mind regarding this specific card is the particular version of the PLC operating system that you're currently using in your setup. Its version must definitely be higher than 2, meaning on older LSPLCs with a version below 2, you can't add this card to them. All right, I click here, and here we need to enable the card. In this section, we do this together and then we click OK. All right, in the Apply section, we click Yes, and here it brings up the list of registers for us. In this section, we definitely need to check the All box and click OK. Now, the list of registers has been added to our global variables, and we can use these registers. Music Kit, do you use them in programming? All right. Right here, I have carefully drafted several specific lines of programming code that are actually related to our same Lutzel card. In this section, I specifically designated the very first line of this entire program. This was done so that we can clearly see if our card is actually ready for operation and is completely free of any functional errors or unexpected issues. Here, we utilized a standard normally closed contact and then mapped the corresponding error signal directly to that specific input. So if there's an error in our card, this will open up for us and we'll realize that our card actually has an error. And this one is related to our channel 0, meaning it's for the Litzel Music channel 0. So the first Letzel is the one we connected to, and this one is also set up separately. There's an error that shows up here if our Letzel has a problem or if the wiring for our Letzel isn't connected properly. This one is also related to the run, meaning we've used a normally open contact. When the card is on, this gets activated for us. And we've also used a normally open contact and basically assigned this relay to it. This relay is related to the card itself being ready because, as you know, the load cell card needs a 24-volt supply to be activated. If that 24 volts is not connected to it, or if the card itself has a problem, this relay will be deactivated. So all these things I've explained to you here are all connected together. We do this so that if at any point there's a problem and any of these don't work properly, our MX0 won't turn on. And if all of them work correctly, MX0 will be set to 1. In the second row, we used 3 MOV instructions. We used one of them for the gross weight, one for the net weight, and another one as well. We used it for the tare weight, and we also connected the enable of all 3 of these MOVs to MX0. So if these conditions are met, we can use these 3 values, and we've set this as the condition in the enable for these MOVs. In the input section of our first MOV, we selected the grass weight related to channel 0 here, so this is channel 0. That means our first latch, grass weight data, which is a 32-bit type, this is something we need to pay attention to. I selected it here, And in the output section, I defined a variable myself called weight. And as you can see, I chose the data type as double word. Its data type is double word. You have a valid address. I assigned MD100 to it here because it's in double word format, so we need to use MD here. If you feel it is needed, you can also refer back to our previous step-by-step video tutorials regarding exactly how to address and fix the issue of double words. The second block is related to our net weight, which is in its input section. We use the net data queue channel, and its data type is also double integer. In its output section, I defined a variable called net weight, and its data type is also double word. I have also specifically assigned the memory address ND200 to this particular section, and our third block is directly associated with the input from channel 0 of add data, which we now recognize and identify as the specific value for our tare weight. That is, if you look at its description section here, you'll see that it says channel 0 is tare weight and live. So this specific part is directly related to our tare weight section, and furthermore, its underlying data type is defined as a double word. All right, in the output section, we also defined a variable. It's called tare weight, its data type is double word, and the address we assigned to it is MD300. Just as we briefly mentioned in the previous lesson, this specific card also comes fully equipped with the zero tare and the tare reset features as well. In this particular step, I have utilized a positive contact component, which is something that we can easily access and use directly from this specific menu right here. To start off, I have defined a new variable for 0 and carefully assigned its specific memory address to the location designated as MX1. What is this for? It's for zeroing. Here, I used a coil, and this part is for channel 0. Basically, I assigned it so that if we read its description, it relates to channel 0, the 0 setting request. So I assigned this to it, and here again, I used a positive contact. I defined a variable for the beam here and then assigned it the address MX2. Also, here I used a coil and assigned it to the beam's channel 0, as you can see in its description. Channel 0 for the beam is the setting channel, and finally, I incorporated the use of another normally open contact and carefully defined the specific beam reset variable for it. I designated and assigned it the memory address MX3 for the music within the system, and I also utilized another coil to complete the circuit. And here I assigned it to channel 0 of the beam reset, which, if you look at its description, is channel 0 of the beam. Release command, which is related to our beam reset, so you select this as well. All right, our program is now ready. We can now download this program onto our compact PLC. So in this section, we set the online connection settings to USB mode. We connect the USB cable, which is used for downloading the program, to the PLC. We've connected the cable. In the online menu, click on Connect. Here, we activate it and upload the program we've written together onto the PLC. We confirm this. And we can also enable its monitoring feature.